solution today. Okay, so here's my beautiful little unit circle that I've made in the past. And then just what you should have gotten out of this, and I've actually written this before in chapter 5, that a 30-degree angle, any 30-degree angle, is an over 6. Specifically, though, 30 does translate to pi over 6 radians. Just reminding yourself of that if you are behind on that. The color coding of this beautiful unit circle has those color-coded there. And I should find, I'll do my notes in color coding as well. I'll turn to a blue, because that's my blues. My blues are all the 45s, which end up all being over 4s. This was chapter 2 that we did all this. Okay? And then green, those are all the 60s. And that's pi over 3. And then if it's not on your written out sheet, stick in the ASTC so that we understand what quadrants we're dealing with, because we need to go fast on this from here on out. We need to pick up those things, like I said before we did chapter 5, like the thing that I just started off class. So what's sine of a 30? As long as you lock that in, lost my pen, that is a half, then cosine of a 30 can't be a half. It's that other one that you wrote a million times in chapter 2 and chapter 3. That's why I'm getting on you on this. At some point, it's got to stick in, all right? So we don't have to keep looking up stuff and keep drawing triangles. If you did, and if you were juniors, which used to be in the past, a lament about that this used to be a mainly junior class, but the way our curriculum's kind of bumped that 1 year later. When you go into calculus, the very beginning of calculus is a whole page of these trig questions, and you're supposed to be done like in 5 minutes. Bam, 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 bam. You know, you're not having to draw triangles. It's through, I don't know what the word is, but after doing something over and over again, it sinks in kind of idea. And then both sine and cosine of 45 is what, everybody? Well, it's fifth hour, and they don't answer questions, but what is that, somebody? Root 2 over 2. You know, so they're both the same. That's why that is not hard to remember. All right? So that's why if you start with sine of a 30 is a half, then sine of a 60 can't be a half. What is it? It's actually on the page. What is it? Root 3 over 2. They switch because you're dealing with the same triangle, but you're just switching who the opposite and adjacent side are. So it's the same triangle, but you're just switching the relationship. So that's why that's like the backbone of like getting these done quickly. All right, and then going from there. So I think I'll formally write it as we've been saying it for 2-3 weeks now, and then also taught it in chapter 2 and chapter 3. All right, so add that ASTC to that component so you know what is positive or negative in what quadrants. And that really is about it. Then when you deal with secant, cosecant, and cotangent, you're just flipping these things. Oh, and by the way, tan, so let's think of tan, I guess I'll formally write that, of 30, this is how you kind of work the coordinates that are listed on my beautiful coordinate plane here, braggy, braggy, but it is sine over cosine. And then this is how you end up getting root 3 over 3, because we know how to rationalize. So the 2's cancel, and you end up with 1 over root 3, which is root 3 over 3. And then tan of 60, which belongs with this down here, is root 3 over 2, sine over cosine again, which ends up being root 3. The 2's cancel, and you get root 3 over 1. So if you have a unit circle with the coordinates, that's what you do with them. You take sine over cosine to find tangent. And then secant, cosecant, and cotangent, you just flip. Did I say secant first? Cosine, sine, and cotangent. So you start with the original 3, and then you flip for the other 3. So this should be enough in order for you to understand that. Okay? I don't know if there's anything else. Everything else is on here. I think it was the ASTC thing, so you know what signs are put on stuff. So we're going to take a day. We did this last year. The year before, we really jumped into it, and I'm not really opposed to it. So you can see your worksheet. That's not what's on your worksheet. Your worksheet looks exactly like my notes. All right, so get this on a separate sheet of paper, and you should be able to handle each section that I cover. And I like this now. So it's interrupted myself mid-sentence. I like what we did last year because I think it logically broke it down. It allowed those that are behind to catch up, but it also those that haven't seen this a while get their mind right in the spot that they need to be for Chapter 6, and then we can progress from here and be successful. The first one, I got weird right away. Right, so, and then I'm also going to add one more thing. Like, what is the reference angle? The reference angle is always opposite the y-coordinate, right? Do you remember that? Okay, so hopefully you do remember that too, because thinking of this, that's what I want to start off with. That is a ratio I'm used to, but what do I really need to change this to so I can look at it correctly? Like, I can, I'm going to write cotangent over here. The program that I use always writes the ratio first, which is kind of weird. But what does root 3 over 3 come from so I can label my sides correctly? Go ahead, yeah. Yeah, and that's how you want to rewrite this. And if you look at your worksheet, the very first one I have is 2 root 3 over 3 as a ratio. And this is what you want to do first so that you can associate your correct sides. Okay, I guess what I should have put up here as well, up at the top, now that I'm thinking about it. An also helpful thing is Sir Kicks or Ticks, yet again. I still have people that don't have this down. When I ask what sign, I don't always get y over r. All right, that's still a problem. So that's why you write that at the top of a test, because that's coming back for this stuff as well. So I'm going to use it right now. All right, so Sir Kicks or Ticks as well. Okay, now what's that make number 1? What letter is that? Because I'll tell you how you really get this down to another way of looking at it. What letter is that? X, Y, or R? Class? It's X, because this is ticks, but reversed. Cotangent is X over. That's how I've always done it. Like as I was finishing off Chapter 3, putting the brain thoughts on a paper. A student relates cotangent to tangent, but then cotangent's the flip of y over x. So this is x, and this is y. Now this is why I want to focus on this. This is the opposite side always. Always the opposite side. Here, I'll go back up to this unit circle one more time and just draw this real quick. This full triangle, just to show you that sine of a 30 is 1/2. Because the side opposite 30 was 1, side opposite 60 was root 3, side opposite 90 was 2. Don't ask me where that came from. That's Chapter 2, Chapter 3, and we talked about it again in Chapter 5. All right, and I proved where those sides came from. But yet again, the opposite side is always the y-coordinate. Always, always, always. So what it always does, it always gives you the reference angle. 1 is always opposite 30, root 3 is always opposite 60, 2 is always the hypotenuse. And then you reduce, or there's a reason why it's called the unit circle. So anyway, what's my reference angle? What is it? It's 60. So this is what I want you to write next. I have a 60, and then you play ASTC. First of all, it is in quadrant 1 because this is a positive. Where else is tangent and cotangent positive? What quadrant? 3. ASTC. So now what you got to do is answer this question from 0 to 360. That's why we're doing this, because it's all the answers from 0 to 360, all 4 quadrants. Well, the first answer is 60. The 60 in quadrant 1 is 60, so that's no big deal. What's the 60 in quadrant 3? Stop looking at your unit circle. You go to the 180 degrees, and then you go 60 past it. What is 180 plus 60? 240. If you are still looking at the unit circle to find this angle measure, you got to stop and train your brain. Okay, you got to be able to think of it that way. It's always off of the nearest x-axis, the reference angle away. All right, and that's how you find that. Oh, I should bounce around the room. I really should. It's a Monday. Maybe I'll give you a break. We'll do it Tuesday. So be ready for this. All right. Cosine of a negative 1/2. I don't have to rewrite that one. That one's ready to go. But is it ready? And where does that negative belong? All right, we'll just see if you follow along here, that the negative belongs up at the top. Because what is -1? 3, 2, 1, what class, what letter? That's fifth hour, nothing. You know, we can't hear you on this side now. So I ask one more time, what's -1, X, Y, or R? Go. Ooh, I heard a Y, and I heard a couple X's. And some people aren't doing jack squat. It's X. What letter is 2? 3, 2, 1, go. R. Everyone should get that one. If you're still saying Y, sir kicks or ticks, get it organized. That's chapter 2. All right, what does that mean Y is, though? What does it have to equal? Because I do need to add that to this. What's the missing side for a 30, 60, 90? And it is, and it does have to be √3 because of the Pythagorean Theorem. Fine, I'll verbalize it. It's x squared, wrong, y squared plus -1 squared, which is 1, equals 2 squared, which is 4. Subtract 1, 4 minus 1 is 3, and then you square root both sides. So anyway, we should recognize the sides that that's the case. Yet again, what's my reference angle? What's my reference angle? It's a 60. And then what quadrants are cosine negative? 60 and what? 2 and 3. Because it's positive in 1 and 4. Okay, so what's the 60 in quadrant 2? Go to 180, but then jump 60 backwards. What is that? 120. And then we already found the quadrant 3, 60, 240. This is how you play the game when you have all the tools in your pocket that you're supposed to have at this point. Okay, and that's how I am going to do it, and we're not going to be doing any more drawings. Okay, so sorry for going into this so fast. This is chapter 6, and what we're eventually going to be doing is solving trig equations by factoring. So what we're doing is building up, though. If we can't do the basics, then we can't do it by factoring. So that's why we're spending a day of really what is chapter 2 and chapter 3, 100% review. All right, then I added these to the worksheet. Little 1-step, 2-step, get the thing isolated. What do I have to do to both sides to get rid of that 3/4? Multiply by what? 4/3. So I'm going to squeeze that in here. And I do realize you're just taking notes, but it shouldn't be that hard to write this real fast. So take a breath for a second with my mask on. And I'm going to squeeze that in here because I don't want to rewrite this. I'm going to multiply this by 4/3. So that means I have to multiply this side by 4/3. That's not a negative, that's a fraction, 4/3. And then this isn't minus, it's just times a negative. So I just got to keep the negative when I multiply. And then here we go again. We got the 4's canceling, and then this ends up being -√3/3 equals tan. Then I'm going to do something fancy. Equals, what does this equal? What do I want to write it as, just like the very first example? 1/√3 is where it comes from. And the reason we're doing that is because, fine, we should know ticks. Y and X, you're not going to recognize that if you keep it as √3/3. You're not going to recognize who the reference angle is and you know what's going on with that. You want to unrationalize it so that you recognize this as Y and this as X. And what is the reference angle? What is always opposite 1 or -1? It's a 30. And it's a 30 in what quadrants? Where is wrong? Where is tangent negative? What quadrants? 2 and 4 is what ASTC says that occurs. So I guess like at the top of a worksheet, this is minimum. You're not getting the unit circle. You're not getting it. But now I'm just like thinking out loud. I think people still have to write sir kicks or ticks. Fine, it takes barely any time. Might want to write sine of a 30 equals a half. And then try to like bounce your head around about, okay, if I have sine or cosine of 30 or 60, that should be enough to put everything in order. And then ASTC, a quick little ASTC coordinate plane. And that should do it. It really should, and I think everyone would do that. And that would be smart just to kind of double check and check yourself. Okay, so quadrant 2. I guess I'll draw this out one more time. What you got to understand is, here's 180, but then I'm jumping back 30. That's why the reference angle is a 30 there. All right, so what is that math? What's going to 180 and then jumping back 30? What do you end up with? It's not rocket science. And then to get this, it's 360 and then back. Switch. And then flip it over. Yep, you did both sides of that, right? And filled out all the bubbles? Got it. And it is your answer sheet, right? Did it say your name at the top? I don't know if I did it. Just make sure it says your name. Sometimes I make a mistake. Hey, what's that last one? Hey, we got all that in the video. I'm juggling here, doing notes, then also getting people making up tests. Taping this for those. Oh, no. I do like this, too, because fractions, your friends and mine. But also, the way this is ordered, how do I get signed by itself first? Do I get rid of the 3 first or the 1/2? Now, people aren't going to answer that, and that's fine. What do you get rid of first, plus or addition or subtraction, or do you get rid of multiplication first? Which one? You get rid of addition or subtraction. This is worded weird, but it's 3 plus. That means it's plus 3. They put it in reverse. So the very first thing you want to do is subtract 3. They do see seniors often have problems with this. Oh, and then how do I subtract 3? Lexi Samulus would get a common denominator, right? So I changed -3 to -6/2. Don't ask me where the 6/2 came from. As a senior, that does hurt my brain. It really does. All right, and then after that, fine, let's get that taken care of. 1/2, because I did explain where it came from too, but then, oh, well then I'm going to multiply both sides by 2, and I get sine of theta equals 1. Now again, look at the global directions, because as we move forward, the directions are going to change. We're still answering all possible answers from 0 all the way up to 360, but not including 360, because 0 degrees is the same as 360. You just want the unique answers in all 4 quadrants. So we're still under those. By the way, 1 over, anyone? 1 over 1. What letter is that? What letter is that? What? It's y over r. What does that mean x has to equal? Okay, that's where we got a problem. That's why, and I'm asking what is x equal before we talk about what kind of triangle this is. Now this is sine, okay, not tangent. So think of the Pythagorean Theorem. X squared plus 1 squared equals 1 squared. What does x have to equal? 0. Okay, so this is where? Where do you get this happen? 0 for x and 1 for y. What degree measure? It is only 90. Okay, because it is only there that you get a positive 1 for y and a 1 for r and a 0 for x. Doesn't say plus minus 1. So there is no there is no other analysis than that. You really got to make sure. This is often said to be a 45. That is not true. That's only if tangent of theta equaled 1 over 1, which would be y over x, when both y and x are 1. All right? So be careful on that one, and then a different answer would occur on that. So little Mickey Mouse couple step solving, because sine of theta is like a variable that you want to isolate. But then after that, you have to answer the trig question. All right, not going to hit all 10 of these, but notice the change in the directions. What does that say? What does that mean? What does that mean I want my answers in terms of? Radians. So now we have to start playing the game. 30s are over 6s, 45s are over 4s, and then 60s are over 3s. And then how do you find the angle measures in the situation? And I'll cover that one more time. These are the things that those that did not do their work in chapter 2 and 3. If you want to make changes, you better really focus on this point. Really focus on the fractional things that you need to do on this stuff. Okay, but then I have a unique one right away. 1 over, switch that with the purple. And then, yeah, walked away for a second. The pen got mad at me. Come on. Come on. Yay. You get to see me live struggling with the pen yet again. And then this is 1 over 1. I don't know if I asked it. So here we go again. x over r. What does that mean y has to equal based off of the very last one that we did? It's got to be 0. Okay, 1 squared plus 0 squared equals 1 squared. Where does this occur? Okay, but then can I answer 2 pi, yes or no, according to those directions? What should I answer as? Just 0. And it is only one answer, and it is 0 radians. All right, that's where this gets crazy with that kind of answer, because I got 0 for a y value, but I got 0 for an angle measure, and they happen, there's no relation, right, between the way those answers have it. I don't know what else I could say. It can't be 180, wrong, pi, because that's -1 for an x value. And that's the same thing what happened with number 4. So sometimes you do get these special quadrantals, and you got to be ready for them. Those are called quadrantals 90, 180, 270, 360. Or 0, pi, pi over 2, 3 pi over 2. Okay, back to this. Oh, I hope that's not exactly that. I think I really made sure the worksheet had different answers. But where does 2 or 3 over 3 come from? Sorry, I forgot you didn't have this written down. So wait. Okay, and then I already got an answer. Awesome. Okay, but I'm going to wait, and then I'm going to go ahead. You know what I'm going to do? I'm going to be lazy. This is the same as 2 over root 3, which was said by a student. So you want to unrationalize. Okay? And not that I'm making that wrong. I'm saying on a test, this is exactly what I would do. I'd scratch off the 2 root 3 over 3 and write 2 over root 3. So I associate my correct things. And then I'll write again what I did at the end of like chapter 3. This is how you should look at this. Now again, this is where we have problems. Whose cosecant related to reciprocally? Sine. So I put a sur above this, but then I did this. Rich. You're going opposite. So what does that mean 2 is? R. What does that mean root 3 is? It's over. I don't have to think about x. That is the opposite side of the reference angle. What is my reference angle? It's a 60. Oh wait, take a breath. But now you hear more people saying the answers. By the way, we got to get the quadrants. Okay, so where's sine positive? What quadrants? 1 and 2. So this is really what you write on your paper to organize your thoughts. Okay? You change 2 root 3 over 3 to 2 over root 3. You get the angle measure reference. What quadrants? Now we're going to go to radians. What are radians over what's? 3s. I'm sorry, what are 60s over what's? I said that wrong. Okay, the first one's easy. In quadrant 1, it's always pi over. That ain't no thing. Now, fumble, okay? This is what I've been doing all year long since we started radians. I'm in quadrant 2, which requires I go here and then backwards. So what I've done is always made this 3 pi over 3 because that's equal to pi. This is not new. I did this like 100 times at least in notes in the video. So if I jump backwards a pi over 3, what do you end up with? 2 pi over 3, because you're not going to have that unit circle to stare at and see the 2 pi over 3, unless you're cheating on a test, okay? But that's what you need to do, and it really isn't that hard. It's just basic fractions. It really is grade school fraction work. And that's it. Okay, why do we do that? The directions dictated that I answer in radians, not degrees. So you got to read the directions and make sure, am I doing it in degrees or am I doing it in radians? Okay? I'm not going to do these bottom 2. I think I'm going to do 8 because we get the idea that these you just have to do some, math, and this one's a little bit more complicated. So I'm going to go to 8. Well, you don't even have the sheet anyway, so just number it number 7. And then 7, 8, 9. 6 afraid of 7. 7, 8, 9. You never hear that joke? Alrighty then. Stalin, so they write it. Who do I, as you write this down, though, get rid of first? The -2 or the -1 over 5? It's the -2 because it's -2 minus. So this is really subtraction in a way. Now I have to undo that subtraction. So I do get some weird undo operations with people. They don't quite get this part of it. You get rid of the addition part, by this subtraction by adding, because it's a -2 minus, it's tacked on like that as an operation. Then I'm waiting because I'm not writing +2 here. I'm writing +10/5, which is equal to 2, which is grade school fraction work. All right, so starting my process of getting cosecant, another cosecant, huh? Okay. This is 2/5. +10 plus a -8. And then instead of dividing, I'm going to multiply by -5/1. And it is multiplication. Multiplying by the reciprocal, because that's a times thing right there. So you can multiply by reciprocal. You could think of division, but multiplying by reciprocal is the smartest thing to do. So these basic grade school equation solving things, I like it, and making you kind of remember your stuff there. Well, that's a nice. This becomes cosecant of theta equals -2. All right, because the 5's cancel and you have a negative times a positive. By the way, -2 over, you need it, because otherwise you can't figure out what kind of triangle I have. -2 over what? 1. That's funny, I keep ignoring 45's. So randomly my worksheet for the work today, the 45's didn't come up happening here. Uh-oh, getting a low battery warning coming up here. My screen just dimmed as a calculator save mode for computer. Okay, so notice what I just shifted. Where did I put the negative, everybody? In the bottom. And this is not a 45, because it's 2 on the top, not what. Let's say that out loud. What would be on top if this was a 45? Starts with an R. √2 is the R value for a 45. All right? So make sure you understand that as well. So this is R, this is Y. Or if you're not sure and you get confused and think it's a 45, do a quick Pythagorean Theorem thing. I'm not writing it down. So x squared plus -1 squared equals 2 squared. You end up with 4, 1, subtract 4, you get 3. √3 is the other, so that's a 30, 60, 90. So what is this? Ah! That's a scratch out on accident. What does this mean? What kind of angle measure am I dealing with? It's a 30. We got one student only still. All right, we should know that that's a 30. Quick question, did I make a mistake? Sometimes you catch my mistakes.
Is that supposed to be an arrow between the -1 and y, or is that minus?
No, it's an arrow. All right, so this is a 30. By the way, again, who's cosecant related to? Sine. Forgot to put that if you didn't know that that was y, and then reverse it. So that's why it's r over y. But also what I need to know is where sine negative. What quadrants? 3 and 4. All students, positive. Take calculus, negative, 3 and 4. Next thing is, what are the 30s? They're over what's? 6's. And those that have been doing your homework, you are going to get quick with this, because this is what you're thinking. Here's 6 pi over 6. Here's 12 pi over 6. 12 pi over 6 is 2 pi. Should not have to explain that, where those came from. What's going past 6 pi over 6? What do we get? Oh, brother. Nobody, even in this 5th hour? 7 pi over 6. Come on, people. I have to get on you for that. Because going past 6 pi over 6, a pi over 6 is going past 30 degrees. That means the reference angle is a 30. Stop short of 12 pi over 6. What do you get? It's 11 pi over 6. And also, you've written these so many times, you should remember that 11 pi over 6 is one of those answers as well. Okay? And then I got 2 more, because we have different ways we can express the answers, and then we'll be done. So the first examples were all in degrees. Second answers were all in radians, just covering all 4 quadrants. But then we've actually had this happen. And it happened to be like when you had to give me the equation of all asymptotes on a graph. Let me just do a quick, what are we shuffling our papers for? Let's make sure we pay attention. Okay, all right. So remember when we had the regular cotangent graph? Let's just go ahead and draw that real quick. And then it was at pi over 2 where it went through 0, and then the period was pi for cotangent. And then the graph went like this. Let's just worry about that part. So this is y equals cotangent. But then remember that this graph went on forever. We had a cotangent over here. If we extended the x-axis, we had a cotangent over here. And then this actually technically was 3 pi over 2. And then it reduced like the, or I'm sorry, decreased. Wrong word came out of my mouth there. And this went on forever. And what else went on forever were the asymptotes. So the first asymptote was located at x equals 0. And then how far away were all the asymptotes after that? What's the distance x-axis wise? Pi. What did I tack on the pi though to show that this happened forever? What letter did I use? No one remembers the letter? N. Nice. You're on fire today. Let's say Matt. It is Matt. Okay, we tacked on a pi n. And then what that n was an integer that I could plug in to create all of these asymptotes. For instance, if I plugged in the integer 2 for n, that created this asymptote because this is located at 2 pi. If I plugged in -1 for n, then that would be this asymptote over here to the left of the y-axis. That was the point, okay? So we have exercised and done this idea because the next set of directions say find all solutions to each equation, and in this case, our first one in radians. Find every single answer forever. Or another way of looking at it, we know the unit circle, we can go through one rotation, but we can go through another rotation and another one. And we could go positive, we could go negative. So to land anywhere on the unit circle, there's actually an infinite amount of angle measures that land in that position. Hence the word coterminal angles. Angles that are coterminal. I'll give you an example. Very simple for pi over 6, which is a 30. An angle that is coterminal to that is 13 pi over 6. Why? 13 pi over 6 is blank pi over 6 plus pi over 6. What's the blank? 12 pi. It's Matt again. And nobody else. So those are coterminal. So I can figure out how to write all answers through an expression using n. We always say n is an integer. Okay, so these are coterminal. That means they land in the same spot. That is what's dictating why we have this idea in directions next. You okay over there, Nick? Looks like you're about to fall asleep on your hand on your head there. All right, I think we may have already seen this one. But what letter is this, everybody? Ooh, someone else than Matt. Nice. What letter is this? R. Here we go. Hey, good foilers. That's just your, yeah, that's your thing. You own it now. You can have it. All right? That's coming up, by the way. 2 days. Good foiling, good factoring. Okay, so what does that mean the reference angle is, everybody? 30. And then where is sign negative? 3 and 4. Okay, now, we have to think of this constructed 9 and constructed 10 on purpose. I am going to go ahead and graph these real quick, meaning where are these angle measures? So first of all, what's a 30? It's an over 6. And I'm going to put those as the answers from the previous section, but then I'm going to put the final answer way over here. So I want to make a distinction of what happens with this stuff. You should already have the answer, by the way. But here's 6 pi over 6. So what is this angle measure here that's in quadrant 3? 7 pi over 6. We should know how to do this. If you really don't, it's really on you at this point. I am putting a lot on you because this is why math is sequential. You know, them saying, oh, do your homework whenever. Hell no, it doesn't work that way. Yes, I just swore. Go ahead and play this point right in the video that I just swore on the video. Don't care. All right? And then what's the one in quadrant 4? 11 pi over 6. Okay, here's my point I want to make on this about all answers. And I have done this before, but it's been a while. Is this yellow distance, I just have a question, is this yellow distance the same as this blue distance, yes or no? No! These two separate answers are not equidistantly away from each other throughout the unit circle like this. That's a good thing for you, because to give me all of these answers, all you have to do is tack on a 2 pi n, because that's the next coterminal angle measure to 7 pi over 6, either subtracting 2 pi from it or adding 2 pi from it. We know 2 pi is a revolution. So that's all answers for that first answer, and then this is all answers for that second answer. And that's really what happens with sine and cosine, and also secant and cosecant. Because my next question is a cotan or a tan, and something special happens with those. Okay, so this is the answer to the question. Not these two, it's not enough. Those are just the two answers from 0 to 2 pi. I need all answers. So I just wanted to cover why we need just to tack on a 2 pi n. So it really isn't that hard. This one is a little different. And I'm not sure if we had this one. I really tried. You know what? I can't believe it. You know what? I'm done with it. Let's scratch this off because I feel bad. Scratch this off and put 1 here. And then you'll know why I did that. Because we've ignored this question. We've ignored this kind of triangle all throughout the notes. Maybe the one I skipped has it, I'm not sure. So I changed root 3 to 1 because I'm changing the question. By the way, 1 over 1. Now you need to know why you've seen this change. What is this triangle? It's finally a 45. I don't know how I skipped those in the notes. So I really wanted to get a 45 involved. It doesn't really matter, but what are those letters? It is x over y, so it doesn't really matter either way. And then this is why this is a 45, because Pythagorean Theorem, 1 squared plus 1 squared is 2, but then you have to square root it to find r. So r is the square root of 2. So I probably would write that up there, because some people, sometimes tell me a 45 is when it's sine of theta equals 1. That's not true. So we have a 45. Where is cotangent? Now look at what it says up here, sorry. Find all solutions, but we're going to flip back to degrees. All right, so degrees, radians, just be ready for both. Your worksheet's exactly the same. I have 1 through 10, just with different ratios here. Okay, so what quadrants are we in? 45 in what quadrants? 1 and 3. And I am going to graph this because I want you to see something, what happens always with cotan and tan when we have to do all answers. This isn't always. You can put this in your pocket, what I'm going to show you next. First of all, the 45 in 1 is 45. What's the 45 in 3? Which you just go past 45, 180. 225. Okay? Now I want you to look at these. Here's 45. Here's 225. Is the yellow distance the same as the blue distance, yes or no? Yes. Always with tangent and cotangent this happens. Because tangent is positive in 1 and 3, negative in 2 and 4. And so is tangent. So their answers are always going to be 180 away. Huh? So for me to write all answers, listen, because then this is always when I get, why did you do that? I did it because what I'm showing you here, I can express all of these answers by taking the first one, and instead of doing 2 pi, or 40, I have no idea. Okay, we're waiting for the pen. Not adding 360, 180. Because every answer is 180 away, so I can express this in one expression. So here's 45. This is when I plug in 0 for n. I am here. When I plug in 1 for n, I am here. When I plug in 2 for n, I am back here. That's taking 45 and adding 360 to it. When I plug in -1 for n, then I'm back here. I can do this forever, guys. And I think we should be able to get this figured out. So tan and cotan we can express as one answer because they're always 180 away in these kind of questions. Sine, cosine, and their brothers or sisters, it's actually easier. You just tack on a 2 pi n or tack on a 360 n because you can't. All right, there's different distances for how far away these are. Alrighty, so it shouldn't be too bad. And it really is a, whoa, I hit the wrong thing there. Really is a building block of what's going on the rest of the way.